No, I'm not ready. So I had a question on 77, part E, that we were just looking at. I don't know if anybody else. So the big mistake people are making on 77E is they're missing that it says 70% spend at least this much time. So it's got to be down here. 70% is at least this. So that and up. So you should be finding a z-score that relates to 0.3, the other side. So that's 77E. Anybody else have a question? Because remember what's happening today. What's happening today?
The quiz.
Quiz. Yes.
Quiz.
Quiz. Chapter 6.
Mr. Waller,
Yes.
for the problem on the board, so to find the z-score of 0.30, you would just go through the chart and find the number closest to it, right?
Yep. Closest to 0.30 in the body, and then you look back out to get the z-score. Something that's got me a little troubled. Does everybody have their z-score table?
Yes.
You better. So can you look up real quick, negative 1.07? What's this area right there? Can everybody look that up real quick? And a z-score, this is normal. This is z-scores. What's that area?
.1423.
So if I write this, what's wrong with this?
That's the area.
Yeah, it's not a z-score. That's the z-score. So I'm getting way too many people that are calculating a z-score, and then you look it up in the chart and you say z equals what you see. That's not a z-score. That is the area below some z-score that you looked up. And then that's kind of messing some people up a bit. So be really careful. Not everybody's doing that, but just don't do that. Anything else, guys, from any homework stuff? Some of these are really freaky, so I expect some questions.
I had a question on homework 6.1. It was number 3. I'm just not sure how to solve it.
Oh, there's no solving at all for that. It's just this idea that we've been looking at. So I know if they say something like this, that is a uniform curve that goes from 5 to 9. I know how to draw it, blah, blah, blah. If they say this, that's a binomial, n is 50 and p is 0.2. And if they say this, get out of there. Or did you get? What are the two most important things for a normal curve? Just for an example. What's the most important things for a normal?
And standard deviation.
That's the mean. That's the standard deviation. So there's no work to do. You just write down the number they already told you. It's just making sure you know what the hell they mean when it's just the way they chose to really quickly tell you what kind of distribution and what are the two most important things.
Got it. Okay, thank you.
All right. Anything else, guys? I'm surprised if there's not more questions. Let me just straighten my house up a little bit. All right. No, everything else is good. I mean, that's possible. I'm all about the probabilities. And there's a probability that there's no more questions, I guess. All right. Okay. Yes.
I had a question on 12. I got kind of confused on how to solve it, I guess you would say.
Yeah, so number 12. So a lot of these at the beginning of a chapter very often won't be any work. So tell me this, what does a z-score tell you?
The distance from the mean to the point.
But then I'm going to be a jackass. If you write that down, I'm going to say miles. Right, so don't give me any more ammunition or reason to be a jackass. I'm a jackass enough. So be really careful. When you say distance, you have to give me what it's measured in.
The amount of standard deviations from the.
Yes. What? So number 12 says, what's the z-score of x equals 9 if it is 1.5 standard deviations to the left of the mean? It tells you the answer in the question. It just wants you to identify it. So the z-score measures the number of standard deviations from the data point to the mean. The only thing you have to be careful about is it positive or negative. So which piece of that is the z-score? Which piece of that is, yeah, go ahead.
Oh, no. Is 9 the z-score?
No, because that's x. Okay,
Oh,
right.
oh, that is x.
So the z-score tells you the number of standard deviations from the mean to the data point.
It's 1.5.
Yes, and now it's below the mean, right? It's to the left of the mean. So it's not 1.5, it's below.
No. Oh.
It's below the mean.
Negative.
Yes, negative. So the mean is 0. And if something's below the mean, that's a negative z-score. If something's above the mean, that's a positive z-score.
Okay.
So that problem, no work. They told you the answer. It's just a question about, can you identify that that's what it is?
Okay. Thank you.
You're welcome. So the first place, I think, is number 15, where you actually have to do work. All right. Anything else, guys, from homework? All right. Okay. I want to say this. There's, I have told you a few times that this book, like some of my colleagues, use the calculator too much. So, and I have made it really clear that I'm not a fan of that. So you can't write on your paper INV norm and that's fine. No, that's not fine. So your calculator did the work. So your calculator gets the credit and your calculator passes the class, goes on and has a nice life, has little tiny baby calculators, and everything's great for the calculator. And then you have to take the damn course again. So that's no good. So for everybody out there who's just plugging in normal CDF and bullshit, I don't want that. No, I don't want that. And if you don't like that, it's too damn bad. You picked the wrong guy, right? My last ass teacher let me push buttons. I don't care. You're not with that person anymore. It's too bad. You're with somebody who wants you to understand shit. So sorry, I'm on a little soapbox today. I'm really sorry, but I was hoping I made that pretty clear. So some people are, so there's somebody had a question. Some people are in the homework. They're just writing the buttons they pushed in the calculator, because the calculator will evaluate areas for you. It will. It'll actually even, like the problem up here, that used to be up here where it was 30%, you had to look at 0.3. There's a button, there's a series of buttons you can push, and it will find the z-score for a given area. Is everybody with me? Okay. And that exists, and that's fantastic. And you can use that to check your work all day long. Just don't think that it counts as your freaking work, because it doesn't, right? This is not Math 100 pushing buttons class, right? Pushing buttons, you ain't gonna pass this class. Pushing buttons class, I don't think we offer that here. Oh, all right. You do it the way we did it in class. So how do we find, so don't give me that shit. So what the inverse norm does, and I much prefer it if you don't even know what the hell it is. How how do we find the z-score right here that's got 0.41 area? How would you find that z-score?
Look at the sheet.
Whoa. Yeah. Okay, I like it. A lot of people answering at once. You find as close as you can to 0.41. So let's all try this. What's the closest you can get to 0.41 on ye old z-score chart? And if you haven't done this yet for yourself, you probably want to print that bad boy out for yourself. I haven't done it, so I'm going to have a harder time. Let me see, where are they? They're there. So what's the closest you can get to 0.41 area?
Negative 0.23.
Yeah, let's take a look here. Let me do it with you guys. Bam. So the closest I can get to 0.41 looks to be right there. Yeah, I agree with you. You guys see that? 0.4090? That looks to be the closest I can get to 0.41. So that's negative 0.2. Sure. 3. I like it. I like it. Now, well, I'm not even going to show it to you. Screw it. Just to remind you guys, while I'm here, did I put that up there? I can't remember. Did I not put it up here? All right, so I'm going to do this. I haven't put it up there yet. The book does a pretty good job of illustrating the buttons to push. I do have a calculator Bible sheet that I would give out. I can put that up on Canvas, but I don't care. You still cannot use those to answer a question. You can use those to check your answer all day, but you can't use them to just give me an answer, because then you're not doing it. You're not actually doing a damn thing, except push buttons. Right? I'm not here to make more button pushers. We've got enough of those in the world. Is everybody okay with what I'm saying? Or does everybody understand what I'm saying? Because whether you're okay or not almost doesn't matter. Okay. God, it sounded so evil. I know. It sounds so evil. Hopefully you guys can appreciate I'm not being evil. But if you can't, oh, too bad. Anything else, guys? Any other questions from homework or from the practice quiz? Or okay. All right. All right. I'm trying to remember if there's anything from the homework that was exceptionally freaky. So what I want to make sure you understand, there's something that doesn't quite translate as a student. If I have something that is normally distributed, so if I have a normal distribution, come on, little dude, what happened to you? All right. That means that I know how the probabilities are splayed out. I have a sheet I can look up. So if I want to, if I'm curious, okay, where's there going to be the z-score that has 0.7? Well, this has 0.5 below it. So if I just go up so many steps, I'll have 70% below it. So then I can look up that z-score. So there's a direct connection between the number of steps I take up or down and the area that's above or below it, because since it's normal, I know exactly the shape of it. And if it's skinnier, say, okay, this thing is real skinny, well then my standard deviations are smaller. So however many steps I take still catches the same amount of area as it would in a wow. Now the standard deviation is huge. So if I take one step up or down, I'm going to catch the same area no matter how fat or skinny it is. That's the idea. So if I have a normal distribution and instead of z-scores, it's got normal means and stuff and blah, 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 it's still the same. It's still If I want to know 70%, what score has 70% below it, I still have to first say, how many steps do I take to get there? And then once I got that, I can change it. Now, all right, let me stop for a minute. So I really want you guys to get that. And that is one piece of why this is Jeff. Hello. This is one piece of why I want you using that chart, is so that you get a better connection with how the probabilities are distributed here. As you look through the chart over and over and over again, you get a better feel for things. It becomes a little more intuitive. Pushing buttons ain't never going to do that. Just to use my really good grammar. All right, maybe. So this guy, if I can figure out what that z-score is, and listen to what I just said. I want to go this many steps above the mean. So of course, to figure out what that x score is, I'm going to start at the mean and I'm going to go this many steps. That's exactly the formula to convert from a z-score back into a raw score. All right. Let's see. So everybody is cool with all of chapter 6 homework as they destroy everything I own. The chart. Okay. That's right. Get off of me there, all right, board. All right, and I got the practice quiz up there. All right, just want to make sure before I transition into chapter 7 where we left off. Just want to make sure everybody's cool with chapter 6 before we take the quiz today. I'm going to assume that's a yes. Okay. So coming back to where we left off, I do have, but let's kind of review what we did. We did a lot last time, if I remember correctly. But it really hinges on your ability to do these kind of problems need to be semi-simple, because we're going to start screwing with parts of this. So what we learned last time is if I'm given a standard deviation. So say I'm given the mean is 48. Standard deviation is 2.9. I like it. Can somebody tell me, what does this mean? What does that statement mean? I know it's strange. You're like, standard deviation is 2.9, Jeff, but what does that mean?
Any data point is going to be 2.9 standard deviations away, above or below 48.
You gotta be careful. This is the standard deviation. So it can't be a number of itself. Yeah, I know this gets a little weird, but I think you got the idea in what you said. This is the average distance. So the data points on average get this far away from the mean. That's what standard deviation is. I like it, which is why it makes sense to use that as a step, to use it as a tick mark to measure distance. All right. So what we discovered last time is, do you know if this is normally distributed?
Yes.
How do you know that?
A normal distribution has a mean and a standard deviation.
Okay, so I love it. Okay, so be careful. I could make a list of data, right? I could just make a bunch of 4, 11, 9, 22, and 0.7. There you go. Can't I calculate the mean and the standard deviation from that list I made?
Yes.
Okay, would that make that automatically a normal distribution?
No.
Okay, good. I'm sorry, I'm not coming down on you. I'm kind of happy you said it that way. You're representing a misunderstanding of a lot of people. So the two most important things to know for a normal distribution are the mean and the standard deviation. But I can know the mean and the standard deviation for all kinds of distributions, right? Didn't we figure it out for the binomial? Yes. Didn't we figure out for the uniform? In your homework, you had to do that. Hell yeah. So what makes it a normal curve is if it has a bell shape, if it follows the empirical rule, right? 68, 95, so forth. That's what makes it a normal distribution. But one more thing. What if I told you that n, so let's take, so from this population, we take a sample of size of, what do you got, Jeff? 42. I like it. All right, I like it, I like it. So this shit right here could look like anything. It could, I don't know what the data is. It could look like, that could be what it looks like and sounds like. I have no idea. All right, I like it. Right, this shit, I don't know. I don't know what this shit looks like. I just know what the mean is and the standard deviation. It could look like anything. It could be freaky as shit. But the minute I do this is what we discovered last time. The minute that my sample size is bigger than what? What's the magic number? Does somebody remember?
30?
30. The minute that I take samples larger than 30, the sample means will be normally distributed. Normally distributed enough. Let me say it like that. Right. I know this is freaky, and I know you all just want me to stop talking. Let me push buttons. Go ahead. I'm sorry. Does somebody have a question? Or is that a sigh of, was that you agreeing with, yes, Jeff, I just want you to shut the hell up and just stop. But I really want, this is freaky shit. It is. Accept that. Accept that it's freaky. Also accept that that doesn't mean it's impossible to understand. Just that it's freaky, right? That's all. So what level makes sense? Normal curve. If I knew something was normal, I have the whole thing of answers. Why? Because if it's normal, it's restricted. It must follow that empirical rule. It must have all the areas in the places that the chart says. So in this, I want to have a way to know if something's normal enough. So this was that alternate universe Florida thing that we went through, remember? Where if I take groups of 30, they most likely will be close to the real mean. But the thing that happens is, once it's greater than 30, it becomes, one, the sample distribution. So if I graph the X bars, that will be normal enough. I keep saying enough because it won't be a perfectly normal, but it will be so close enough. We can go ahead and use that chart. And then the second thing that happens is that the standard deviation changes. Remember that? Since if I take a group of 30, it will be much less likely that their average will be really far away from the overall average. They should be close. Everything should get closer. It should be harder for a group of 30 to have an average far away from the real average. So what happens when everything kind of comes in, the standard deviation gets smaller. That's what we discovered last time. And this is called the central limit theorem. How important is it to know that? Not very. I call it the CLT. I also call it chicken, lettuce, tomato. Whatever it gets you through. Or it's a cult. Ready? Join my cult. Yay. No, don't worry. I'm not going to make you drink any Kool-Aid. Don't worry. All right. So if I'm given this information, but they don't say it's normal, I can't do shit. But the minute they say, oh, we take a sample of 42 and they ask me a question about the sample mean, now I know I'm dealing with a normal curve. So the individual data points could look like freaky shit. But if I take every group of 30 and plot them, they must come out pretty damn normal. They have to. That's the point of the central limit theorem. So, you know, that's the one side of things, is the conceptual side, the side that I understand people hate. I know there's people out there just going, okay, what the shit do I do for homework? What does this mean, Jeff? What does this mean for me? I get that. I understand. So here's what that means. I'm going to take this away. So in this problem, if I ask you, what is the probability that the sample mean of the 42, what's the probability that the sample I took has an average greater than 50? I can do this problem since n is greater than 30. So if it doesn't say it's normally distributed, I cannot use that chart unless they say we take a sample and it's bigger than 30. So the sample size is bigger than 30. So I can draw this now. I know it's normally distributed. What goes in the middle?
48.
48, kick ass. And I want to know greater than 50. So I put 50 down there. I want to know that area. What's the next step to try to get that?
Find the z-score.
Find a z-score, kick ass. Because that's the only way I can use the chart of answers, is to get a z-score. So it'll be 50 minus 48 divided by what?
2.9.
Uh-oh. Sort of a trick question. This is the spread for individual data points. Am I asking about individual data points here? I'm asking for about sample means of samples of size 42. This will always mean the spread of individuals. So if the problem is about a group bigger than 1, I can't use this number. It doesn't go with that. How do I figure out the right standard deviation to use for a group of 42?
Once you take the standard deviation and divide it by the square root of n.
Yeah, I think that's what somebody else is going to say too, right? So take the old standard deviation. I call this the old standard deviation. It just means the one they gave me that's for individuals, and change it into the one that works for groups of size 42. This is what that does. All right, that's a lot to take in. I know it is. So this standard deviation works for individual data points. How are they spread out? But that's not what I'm working with. I am working with a group of 42. So I need the spread that relates to groups of 42. So whatever the hell that is. 0.5 something maybe?
0.447.
447? Okay. So that is the standard deviation I would use there, not this one.
$4.47.
4.47?
Yes.
That's kind of freaky. And of course, I had to pick numbers that ended up here, but what does it mean when I'm off the chart? Isn't that off the chart? How much is down here then? You could say one of two ways.
0.9999.
Yeah, so officially it's 0.9999, so what would this be?
0.0001.
I would also accept about 0% because that's about 100%. So either you can do it but this way or that way. Either way, it's fine. As long as you understand both of those. I'm sorry. So let's see. I get a question. So it doesn't matter if they're spread out weird. Oh, okay. I really want you, the thing about the central limit theorem says, the individual data points can be spread out any way. It doesn't matter. They could be spread out like weird shit. I would never be able to answer a question about the probability of one person because they didn't tell me it's normal, so I don't know what it looks like. But the minute I take samples greater than 30, if I were to plot all of them, it would turn out normal. So I go from freaky shit to normal the minute I'm over 30. In fact, the prettier it starts off as, the less sample size I need until it becomes normal, but we just make it 30 just to be sure. And I want to, all right, I'm going to try a different problem. Let's do another example. And then I'm going to unleash you on a worksheet, but is there a question on that problem?
This is like, it's not a question specifically for this problem, but like, as you said, like if it's prettier and it's under 30, then like, could we assume it's like normal? Like if we get something that's like 28 and it looks exactly like a normal curve?
So we, for example, we did that colorful worksheet, remember, with the numbers that were in a hat? And then I took samples of size 2 and immediately looked really normal after n equals 2 because it started off uniform, which uniform is nice. When I say pretty, I mean not crazy. And uniform is the opposite of crazy. It's like, it's boring, which in this case is nice because it's predictable. In this class, we need n greater than 30 to be sure. If you took higher level stats or if you use some kind of statistics in the real world, there will be a way to determine what's an acceptable sample size. And it doesn't have to be 30 based on how close to normal it already is. Does that make sense?
Yeah, thank you.
Okay. Now, that's not something we're going to get into in stats 1, but it's kind of easy to see that could be true, that there's got to be a way to determine how big of a sample based on what it looks like already. So if you plot it out and the data looks normal to start with, then you don't need exactly 30, but we don't know how to determine exactly how big of a sample yet, not in stats 1. So, anything else about this before I take it away? All right. So the other part of this I want to emphasize is basically what we were just talking about. What if I tell you, in fact, every problem we've done so far is exactly like this. We have a normal curve. This is all the problems in chapter 6. We have a normal distribution. The mean is, it's hard to come up with a bunch of these. And the standard deviation is 0.56. Yes, right? Can I answer a question about an individual data point now? So if I pick one data point, find the probability that it is less than 2.11. We've done this problem before. Why do I not need sample size greater than 30?
It says it's normal.
It already says it's normal. So all right, is that cool? So we've done that shit. If it says it's normal to start with, I don't need a sample size to save my ass, right? The problem we just did, I didn't say shit. It could have looked like anything. So I needed greater than 30 to make sure I could actually do the problem. Because if I don't, I can't use the chart of answers. I got nothing, right? So, okay, do that problem. I'll wait. This is chapter 6. This is what the quiz is on today. You kind of should be able to just eat this one up. draw the picture, make the z-scores, look it up. You might be right. Let's see. Ha, 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 ha. So how do I set up the z-score formula while we go up here?
2.11,
Good. My data point minus
2.89.
0.89. That tells me how far it is from the mean, and then I divide by
0.56.
0.56, because that works for individual data points. And that's exactly what the question was about. Bodacious.
Negative 1.39.
Negative 1.39?
9. Yeah.
Okay. Is that what everybody else got?
Yes.
Okay.
Yeah.
Sorry, I don't not trust you. It's just better to have a crowdsource. Okay. So this would be 0 if I wanted to make that a z-score course. The mean always. This would be negative 1.39. I looked that up and I'm done. Kick ass. Right? So what do you get when you look up negative 139?
0.0823.
Is that what you guys got? All right, 8.23%. Okay, good. 11. So that's chapter 6. So this would be part A. Now let me show you part B. So let me put this up here in the corner. The probability that one data point is less than 2.11, we got 0.0823. I'm going to want to reference that here in a bit. So that's part A. So here's what part B is. This is the kind of problem I love to give on like a chapter 7 quiz. So here's part B. Part B, what are you doing? Yeah. Part B would say we take a sample, of 8 data points. Blah, blah, blah. What's the probability that the average, oh shit, well, okay, there it is less than 2.11? Is it okay that that's not greater than 30?
Yeah.
Hell yeah, we just did one, right? So be really careful. If it's already normal at the beginning, the sample size could be anything. It's because it's already normal. It doesn't need a process to make something become normal because it's already normal. But what's got to change? If I just do this problem, I'm going to get the same answer. That's not right. What's supposed to change?
Standard deviation.
Standard deviation. So that's the first thing you do. So it's going to be the old one, the one for individuals, divided by the square root of
8.
8. So roughly 0.2, maybe?
Yeah.
Is it?
0.197. Or
Ooh, I like it. 197?
0.198.
98? Okay. And now, so remember what I told you. This is the only new thing chapter 7 gives us. After a lot of explanation, that is the only nuts and bolts thing that happens in the work. Now I make a z-score like I did. I can draw my picture. I put the mean in the middle. I put my 2.11. But now when I go to make a z-score, I divide by 0.198. It's gonna be like is it maybe a 4 again, Jeff? You just can't get away from that, can you? Wait, it's point. Yeah, it's like 4. Shit.
Negative 3.9.
3.9?
4.
4. Which again is off the chart. I'm sorry. I just can't. I thought I had something. Anyway, it's off the chart, which means what's down here?
0.0001.
Okay, officially, or about 0%, either way. So I want you to realize something. The probability that one data point was less than 211 was about 8%, roughly. If I take a sample of 8 data points, that probability goes down to just about 0. It's very unlikely for it to be out here because when if that's the original picture, the new picture looks like this. Everything rushes to the middle. The standard deviation is smaller. There's much less out there than there was before. So of course that probability is going to go down. More stuff went in, less stuff out. So I love asking part A, part B, and then part C, explain the difference between the two probabilities. Well, there's less shit out here, so there's less probability. End of story, Jeff. Next prob. Yay. All right, maybe. By the way, just to remind you guys, this is not on the quiz today, is it? This is today's quiz is chapter 6. Don't do any of this weird shit on today's quiz. Don't. Right? Okay. Because that's chapter 7. That's not on the quiz today. All right. So let's, okay. All right. So there is a handout up on Canvas that I want you to get, if you could please. It is under Unit 7, incredibly enough, and it's called Chicken Lettuce Tomato Practice. Man, now I want a chicken sandwich. So just to show you, in case you're having trouble, if you go to modules, and you go down to Unit 7, there's that sampling distribution one we did last time, and then there's practicing for a cult. So I want you to do it. I want you to do that sheet. I'm just gonna sit here and do nothing. Taxpayers scream about greedy teachers. They ain't doing shit. Sit at home. That's true. Watch me. I'm just gonna sit here. Ha. Does anyone need me to share this? Is anybody not able to access this on Canvas right now? Anybody? So everybody's able to get it themselves? All right, let's see if everybody's paying attention. Bam, let's go. Here, I'll put it back up there. I'll put it back up there this way. Oh, I can also stop recording for a while. That for me. I always forget. Okay, so let's do this thing. Share this. Let me see here. Okay. All right, guys. Hopefully, let me see who is. Okay, looks like everybody. Oh, there. Bam. Okay. So this first one is pretty straightforward. I know it's normal already. What goes in the middle?
2.90.
2.90, I love it. And then I got more than 3, so I want to find that area. So I just got to change 3 into a z-score. There's the standard deviation I'm going to use. So what's that come out to be?
0.32.
That makes sense. I like it. And then when you look up 0.32, you'll get this side. I think if I do this, can you see the z-score chart now?
Yeah.
Okay, thank you. So 0.32, I get 6255. So how do I get the actual answer?
1 minus.
Yeah, so 1 minus 6255. Shabam. And I don't know how many people, if you look up negative 0.32 and you just get the answer right away, it doesn't matter. It doesn't really save you like a ton of time, but it's still a nifty little shortcut. You desperately have to be cool with this kind of problem right here. Especially because you're having a quiz today on it, but you know, just in general. So what changes in part B? I don't know if I like purple.
Standard deviation.
Standard deviation, kick ass. So the new standard deviation is going to be the old one divided by the square root of
22.
2, kick ass. And then what do you get when you do that?
0.066.
I like it. I'll throw that in there. I like it. And again, you can go further. You could say 0.0661. You know, it's at least 3 places, so it's up to you. Now all the steps are the same except when it comes to this step right here in the work. All the work is the same, except I'm not going to use that. I'm going to use that. So I got my 2.9. I got my 3. I want to find this area. I make a z-score. 3 minus 2.9 divided by the correct standard deviation. It's like 1.5 or something, is it? Did I do that correctly?
I got 1.52.
Oh, come on. I did it in my head. So, but all right. I agree. I like that. So Nick's like, not good enough, dude. Math boy. Come on. Step it up. So when I look up 1.52, I'll get that side, and I just have to do exactly. So every step is the same in part B. The only thing is I can't use that standard deviation. So what do you get when you look up 1.52? Looks like 9357. Is that what you guys got? Holy shit. All right, give me a second. All right, that's better. And then 1 minus that'll be 0.063. How's everybody out there? You guys all right with that? I could be wrong. I could always be wrong. So.
You're right.
Okay. Thank you. And just to point out, there is a over 30%, 7% chance that a single woman has above a 3 bone density. But when I have a group of 22, it's going to be much less likely that they have such a great bone density on average. That would mean that each one of them would have to have a decently high, or if somebody has a low one, someone would have to have freaking Wolverine bones to compensate. And that is very unlikely. So the probability goes way down from 37% to just over 6%. Okay. I love it. I like to count the number of yawns I see as to how much I should move on. All right, so this is interesting. I actually looked it up here because I made this handout a while back. It wasn't 2004, but I think that was the last credible data I could find. But look, this is really fascinating. Now this, I want to tell you guys something. Anybody out there taking English right now and you have an instructor that's like, don't even look at Wikipedia. Don't even, does anyone have? All right, that's bullshit. Tell them Jeff Waller said that's bullshit. You don't want to know why? Wikipedia is an awesome place for sources. Sure, you don't take what they say at face value. You check out the sources down here. Hello. Sorry. So a little tip from Jeff. When you're trying to do a research paper or an essay or something, don't cite Wikipedia. Go to these sources and then see if they meet the criteria your teacher gave you. Anyway, that's enough. Listen. So you could double check all these data points through these sources, and they check. This is by state. So California, oh shit, where am I at? Here we go. What is this down here? Oh, screw you. All right, so California, where am I at? Oh my God, they got a lot of shit here. In 2018, California, we were ranked number 2 overall. What's really kind of sad is look at the disparity between the different races. Look at how spread out those numbers are, right? And what's really interesting to me is look at the district, look at DC. DC has one of the worst life expectancies, right, for black people. And then if you look at, in terms of white people, they have the best. So that is really, I'm not even sure what word to put on that. So, you know, that kind of, if you've ever been to DC, has anybody ever lived in DC? If so, I'm really sorry. It does need some help. It's not the best place. Anyway, all right. Enough of that. So coming back to this. So why is it okay? Oh, somebody's chatting at me. Oh, I'm sorry. 1B was, let me write it bigger, 6.43%. So what about this? Why is it okay to use the z-score chart for this problem? You're welcome. Why is it okay? Anybody?
The sample size is bigger than 30.
Yeah, so as long as they're asking me a question about the sample mean, so the two things I need to have happen to know when to do this little dude here is there has to be a sample size given, and I have to ask a question about the sample mean. The fact that it is bigger than 30 tells me I can look the z-scores up in the z-score chart to find probabilities. All right, so the new standard deviation is going to be the old one. Uh-oh, somebody's chatting at me. Too much technology. Oh, there you are. Okay, I can see you now, yes. Okay. Where am I at? Oh, yeah. The old standard deviation, oh, there's, okay, all right. Divided by the square root of the sample size, which in this problem is 37. All right. And then what do you guys get for that? I get about
2.450.
All right, I can deal with that. 2.450, I like it. Does that jive with everybody else? Then I can draw them a picture. I know it's normally distributed because of this. I put the mean in the middle. I got my 75 years, and I want the probability somebody kicks it before there. So now I'm going to make my z-score, and I just be sure that I use the right. I don't use that standard deviation. I use that standard deviation. That's going to be something like 2.08 negative. Complete data. What is it?
Is it negative 2.12?
212? Okay.
Yeah.
I did it in my head, so you gotta, again, I love you guys. I love that you're not even giving me anything. You're like, come on, man.
You're close. You're close.
You were like 0.04 off, and you're a math teacher. What am I doing in this class? I'm really sorry. I'm really sorry. While I'm thinking about it, on that note, in Canvas, you should see a link to evaluations. So I am being evaluated this semester. Every 3 years we are, just to make sure we haven't gone insane. So go ahead, and it's a nice check they do. They're like, the students would probably tell us if they were insane, right? We'll find out. So you log into Canvas, there should be a link to evaluations. There might be other instructors you're taking that are up for evaluation. So maybe you get to fill out more than one. And just let them know how great or horrible I am. Oh, why did I circle that so much? So that Z is negative 2.12. So how do I find the area? Let me erase that circling. How do I get that area?
The chart.
The chart's crazy. 2.12. So I get 0.0170. Be really careful, by the way. I noticed somebody was always 1 off. Remember, it starts at O. So this is 26012, right? I think somebody out there is starting at like it's 1, 2, 3. Do you guys understand what I'm saying? This is O. And I already forgot everything we just did. 212. So that's 21012. There's 212. So 0.017. So just under 2% would only live up to at most 75 years. Under 2% would die before they hit 75. All right. Last 2 problems, and then I'll let us out of here. Let's see if we can do this a little bit quickly. So this problem is the same problem. I just have 2 ages to work with now. So I got to make 2 z-scores. So 81 up to 83. I make a z-score for 81. What was it? Where'd you go? There it is. Let me see. Would it look better if I did this? Anything that makes my writing look better would probably be a good. Oh, that's a little better, isn't it? Is that better? Or nothing makes it better? I understand. Yeah, you guys got to read this. I got to live with this as my handwriting. I mean, my God. So let's see. Six divided by 5, 3.2 divided. Let's say that's like 0.32. Let's see. Maybe like 0.34.
0.33.
Oh, okay. I was right in the middle. And then this one, I don't know. I haven't thought about it yet. Oh, that's going to be 7.6, 1.06. Wait, 1.16, 1.16.
1.14.
You two kids can do that. So you look those 2 up, right? It's the same stuff as before. The thing was I had to use a different standard deviation than what they gave me, right? Because it's still about the sample mean. So let's see, if we look up 1.14, I get 8729. So that's this 0.8729. And if I look up 0.33, I get 6293. So that's 6293. So to find the area in between, I just subtract those 2, and I get 0.2436, maybe?
Correct.
Sweet, thank you. Uh-oh. So unfortunately, it's not a skill that I could do like out in Balboa Park and get money for it, but oh well. Yeah, I think. The Wizard of Math plays. That's me. this was the freakiest one on here, but I did help you guys out. If you do look up, and look, that's 0.95 there. So how much is down here?
.0250.
I like it. And if you look that up in the chart, you get something exact, which we're not used to. You can find exactly 0250. So let me show you. If you look up 0.0250, look right here. Look at that shit. You don't see this all the time. That's perfect. What z-score is that? Negative 1.96. So what z-score is this?
1.96.
1.96.
1.96. Can you guys see where my cursor is when I do this? Can you guys see my cursor? Just play with me for a second. Can you see where my cursor is, anybody? No?
Up at the top.
What if I do this? Is that changing it? Can you see it?
I don't see anything.
Shit, all right. I was hoping this other button would do something. All right, I'll stop. I'm sorry. Now you can see it. There he is. Hey. So now what I've got to do is I've got to change both of those into sample means. So I'm going to use the exact same formula, mu plus z sigma, but I can't use this, can I? I've got to use that. Same formula as before. I just have to use the right standard deviation, right? It's the same exact formula we used them before. So it's going to be, what was the mean? 80.2. Let me do this even, plus or minus. Let me see how you guys think about that. 1.96 of these, 2.45. Is that cool, plus or minus, right? It's down 1.96 and up 1.96, isn't it? So it'll be, I don't know, I might be running out of, oh, there we go. 80.2, give or take. What's 1.96 times 2.45? I get 4.802. So really quick, I just want to make, if I go up almost 2 steps and down almost 2 steps in a normal distribution, I catch 95% of the data. So that's what I did. If I start at the mean and I go up almost 2 steps and I go down almost 2 steps, that's exactly what that is mathematically doing. So now I do 80.2 minus 4.802. I'm brain dead. I'm not going to try to do that in my head. I'm starting to fade. Oh, shit.
75.4.
I like it. 75.4 up to
85.0.
Yes, I like it.
shit, 85.0. So
What I
between
got,
75
I
and
like it.
85 roughly is 95% of the data. Woo. All right. I think that's enough. I'm tired. My poor little brain. I need to stop. All right, guys. So what time is it? Oh, yeah. So the quiz is active now if you want to start it like soon. And it's due by tomorrow at 4 p.m. So there should be plenty of time somewhere in there. You could find some time to do it. I'm sorry. Scroll up.
I got lost where you have 4.802.
Oh, here.
Yeah.
Are you lost as where that came from?
Oh, did you multiply the 1.96 with the 2.45?
Oh, yes.
Okay, thank you.
Because, of course, our operations have got to multiply before add subtract. Yeah, I like it. This, by the way, this idea is going to be what Chapter 8 is all about. Believe it or not. Believe it or not. Sorry. All right. That's plenty for me. Does anybody still need this up here? Uh-oh. Yes, yes, I will. Thank you, miss. Everybody else are? Oh, here's another chat. Oh, is it not up there? Wait. I might, did I not publish it yet? Hold on. Let me stop sharing for a minute. Let me make sure I've got the quiz. Oh, shit, Jeff. What are you doing, buddy? There you go. Hold on, everybody. Oh, I didn't even create the submit thing yet. No, quiz 5 should be there. Tell me you can see quiz 5. somebody. You should totally be able to see quiz 5. If you go to modules, let me
I can
show
see
you.
it.
There.
I just have to create a place to turn it in. That would probably be good. So if you go to modules, it's the second module down. Oh shit, no, it's not there. Oh, I see what I didn't do. Here, I'm gonna do it right in front of your face. Quiz 5, add. Okay, that's what I didn't do. I created it, I just forgot to throw it into the module. I'll create a place to submit. You don't have to watch me do that shit. All right. Anything else, guys? Let me do this right now before I forget. You're welcome. Welcome. You're welcome. All right, let's edit. Let me know if anybody has a question as I do this. I do birds. Suddenly every time you are near. There we go. That should be. All right, guys. I don't see any questions. I'm going to head out. Bye. Bye, everybody.